हाँ अरे थांब ना जरा, 15 तारखेला. So we will continue with non-conventional machining. So we have seen abrasive jet machining, we have seen abrasive water jet machining, and we have seen electron beam machining. So now, hello, can you see?
Yes, sir.
Yeah. Somebody is asking. Anybody is asking anything? No, no. Okay. So it can be basically divided into three parts. It can be classified. That is thermal or electro-thermal process, and chemical and electrochemical process, and mechanical process. So mechanical process means the material will be removed with the help of the pressure. So that is your mechanical processes. So your abrasive jet machining machining comes under this category. Thermal and electrothermal means only pure thermal means because of the heat, and electrothermal is nothing but because of the electric current and heating. So the electron beam machining comes under the category of electrothermal. Electric discharge machinings again electrothermal. Wire idiom electrothermal. Laser beam machining this category. Then you have chemical and electrochemical process. So chemical means no electricity, no electric current. So the material removal rate is only because of the chemical. This you are already familiar, chemical machining. Like suppose if you keep any component in a chemical, then after a few hours that component gets eroded. So that is a kind of a erosion, and there is a kind of a machining. So that is nothing but a chemical machining. But if you want to expedite, that is if you want to make it fast, then you also make use of electric current. So in that case it becomes electrochemical. So your electrochemical grinding, that means use of electricity as well as chemical. So ECG, then electrochemical honing, electrochemical machining, chemical milling. Hmm. So chemical here, out of this only chemical milling comes under the category of chemical. EDM and Viridium we are going to study in detail because the weightage for that is 10 marks.
Hello. Oh, oh.
So EDM and YRDM, we are going to take it in detail. So, but I'll just give you an just broad view about EDM. So, as the name suggests, it is electro discharge machining and it is used for hard material. So, this is the setup for EDM. You have a electrode, and the shape of the electrode is exactly it will look like what you want to machine in the workpiece. Hmm. So, whatever the shape of the electrode is, that is what you will get it in the workpiece. So it works on the principle of electrical discharges. So so there is a voltage applied, very high voltage, and that will generate a spark across this electrode. And because of the spark, the material will be eroded or material will be removed. That is what is your electro discharge machining is. In wire cut EDM, uh, so this is used for blind component, blind. uh, Now, wire cut EDM cannot be used for the blind component. There has to be through and through component because in this the wire has to pass. This is the workpiece. This is a component. The wire has to pass. So there has to be a hole, and then see this is the profile which is to be machined. This profile. So this also works on the principle of cutting by sparks. So high voltage is passed and the spark is developed. Only difference between wire EDM and normal EDM is here there is a wire which is continuously moving. See, this is a wire which is continuously moving, hmm, and there are sparks, coming and sparks which are surrounding the wires, and because of the sparks, the material is cut, the material is eroded. Hmm. Both are CNC, wire cut EDM as well as your EDM, both are CNC. Wire cut EDM में you can develop any complex profile. These are the components which are produced by wire. These are mixed actually, wire EDM and spark EDM. But any complex contour can be machined, but limited to two-dimensional cutting only, 2D cutting, limited to only 2D cutting. So 3D cannot be generated with wire cutting, but 3D can be generated in EDM. So we are going to study in detail. There are various names for EDM: electro discharge machining, spark erosion, or die sinking, or cavity machining. Remember, EDM is used for machining hard material and machining conductive material. So, if the material is that is material means workpiece material is non-conductive, you cannot use EDM. That is the biggest disadvantage of EDM. Now, research is going on at how to use EDM for machining non-conductive material also. So that's a area where you can also uh, use or put your efforts. Presently, the scenario is the EDM and wire EDM can be used for conductive material only. The workpiece has to be conductive. Hmm. That means it cannot be used for cutting plaster things. For whichever doesn't conduct electricity, it cannot be used. So this we'll see later on. Hmm. Now we'll go for laser cutting. Yesterday we discussed AJM, AWJM, EBM, and we were discussing about laser. So laser, as I told, that in the childhood we must have used, a lens, and we have converged the sun rays so that your paper burns, or if you converge that rays, on the skin. Your skin also burns. That's nothing but erosion. So the beauty of laser is that it doesn't get scattered, scatters. So it travels in a straight line. So the laser which is used for presentation, the light travels in a straight line. It doesn't get scattered. So energy is focused, and that's why it has medicinal applications. Medicinal applications like cataract. Cataract is nothing but a generation of a fungus on the retina, and that's why you
Oi,
having
Kunjan. Oi,
this. Hello,
oi.
hello. Yes, you want to ask something? So cataract is nothing but a slight fungus which is developed in the retina, and then your eyesight becomes you start looking blur. So what happens in laser cutting? You direct a laser. hmm, That is, you drill a small hole near the eye. So that is nothing but engineering only. You drill a small hole through which the laser is passed, and you have to drill one more hole, a small hole, where that cataracts is nothing but the chips in our language. Whatever is being melted or whatever is being cut, that is nothing but the chips. So they are collected from the other side. And this process is called as the phacoemulsification in medicine. And it hardly takes 10 to 15 minutes. And the patients, they are asked to wait for another 15 minutes, and he is ready to go home uh, within half an hour after this operation. Same process for the kidney stone also. Kidney stone is nothing but because of the bad habits, that is, you drink, not drink, water. There is a formation of small stones in the urinary tract, and that obstructs the flow of urine. Uh, and the urine flow is very painful because of the stones. And then in this surgery, what we do first, we do sonography, and with the help of sonography, we first detect where the stone is, because that stone is not fixed. Sometimes it keeps on moving also because of the pressure of the water. So first to detect where the stone is, and then again drill the hole, pass the laser, melt, crush that stone, and remove or suck that chips on the other end, and again it's again takes another half an hour. So it's a beautiful technology. So like medicinal, it has engineering applications for cutting your steel and everything, laser cutting. So you can imagine it is like a milling machine only, but instead of milling tool you have a laser source. That's all. So basically it's nothing but a CNC milling machine. The spindle is not rotating. Instead of milling cutter you have a laser source. And the full form of laser, it is light amplification by stimulated emission of radiation. You have learned already in your 12th physics as well as in your first year engineering in engineering physics. Again, here the laser source is important, and laser source are not manufactured in India. We still have to import. So again, if you concentrate your energies or if you focus uh, on manufacturing of laser source, you can be a millionaire in one night. You can become a millionaire in one night, because all the source laser source are imported right now in India. We don't have technology to manufacture laser source. So that's again a virgin area in India. So this diagram you can draw that you have a lamp here, then there's a reflective end, then laser crystal, then reflection, your lens. It's a double convex lens which is used for. Hold on.
Take
and, and because of this convex lens, the lens it is converged. It is converged, and the material is eroded. And again, it's a CNC laser machine. Most of the laser machines are CNC. So it can be used like a cutting as we do in CNC milling, or it can be used as marking also. So marking on the beauty of laser is it can be used for the marking. Laser marking is very popular. Why it is popular? Because laser marking can be done on very thin components also. 0.2 mm or 0.3 mm thickness component also. Laser marking can be done. Hmm. Either you can do laser marking or you can do etching. Etching is other way if the components are very thin. Thin means we are talking about 0.2 millimeter or 0.3 millimeter thick product. So all of you know the principle. It stands for light emission. When a quantum of energy from a light source is made to fall on a medium like ruby, ruby is a crystal. Its atoms absorb the radiation. So this has to reflect. This has to reflect in your answer. This is being principle of laser. This is being important. In the photons, it emits a photon, right? And they excite other atoms, the secondary emissions, and then this chain reaction it follows and it causes a spontaneous emission. This you need not draw because that's a physics which is not expected. That is photon emission model. Hmm. Because all of you know this that this is nucleus. In the nucleus you have proton, neutrons, and there is a electrons which is orbiting in ellipse, and you supply some energy. You excite the electrons, and in if some electrons are in excited state, it no more remains in the orbits, whether it is 1s, whether it is 1s2, 2s2, p, f. Once it is excited, like it no more remains stable, it becomes unstable. And then what if the electron is in unstable state? Then it has to fall somewhere. Okay, so it jumps from one orbit to other orbit. Right? And in this jumping, when the electron jumps from one orbit to other orbit, there is a conversion of energy. Uh, that is as per the law of conservation of energy. uh, so we get a light, we get a light when it's excited, and that is nothing but light particle is nothing but the photons. And there are so many electrons.
Hello.
There are many electrons, which
Hello.
are becoming unstable,
Hello.
which gets excited, and which
Hello.
moves from ground state to excited state. And during this,
Hello.
fall downs, uh, you get a you get
Hello.
a light.
Ah,
Hello. नहीं नहीं So this is what is our physics is semiconductor physics is photon emission. How does the and during the jumping, that is when the electron jumps from one orbit to other orbit, uh, the photons are generated, and that is what we called as the this laser effect. So the laser cutting machines are, you have tabletop model which are used for engraving, as well as you have huge machine which are used for your cutting also. So they are available depending upon your requirement. The machines are available. This is medium size laser cutting machines. The cost of the laser cutting machines, it starts from 2 lakhs and till 7 lakhs. This is the application of laser beam machine. Now here, what we are doing, here we are cutting elliptical slot. Remember, it is very fast, and laser beam machining can be used for hard material machinings. And not only hard material machining, it can be used for composites, then plastics and ceramics. You know very well how hard your ceramics is. You totally get a burr free component, that is you don't get a burr, and that is the most advantage. So it eliminates that deburring operation. It is a secondary operation, and that is what is called as the clean cut. इसको हम लोग क्या बोलते हैं? Clean cut. Clean cut means burr free. See, deburring is again a secondary operation. Deburring is again a secondary operations, which again takes a time and energy. And what happens, like suppose if you simple example, like suppose if you drill from top here, then you get a burr at the bottom. Okay, and if you want to remove that burr, then again you have to do you have to use a larger drill to remove that burr. So again the burr will get folded. So like suppose if you have burr here, is a small burr here, and if you try to deburr it, so it gets folded inside. Then again you have to deburr from here, so it's folded upwards. So like that, 4-5 times you have to do deburring from top as well as bottom, so that you get a burr free component, totally burr free component. So it is time consuming. So if any process which is giving a burr free component is always welcomed. So LBM, the advantage is you get a deep burr free component. Then laser apparatus, uh, basically it has a mirror. uh, any mirror will have its specific focal length, so that will decide its range, hmm, area, how much it will work. Then source of energy, then an optical amplifier, that is a ruby rod or a glass filled tube. Material removal rate is very less. All these unconventional machining processes, everywhere the material removal rate is less, and they are expensive. Only the EDM, it's a trade-off. EDM and YDM is a trade-off. That is, you get a better removal rate and you get a good finish also. But if you want a good finish, then you have to compromise on the material removal rate. Laser accuracy is not that good. That is the disadvantage. Laser accuracy is not that good. It's plus minus zero point 0.1. So if you're talking about 20 micron, so this is 100 micron. 0 plus minus 0.1 mm, it's 100 micron. That is, you multiply by 1000. So if you want 0.02, laser fails. Laser fails. But it can be used for the small holes, right up to 5 microns. It depends upon the source, basically. It depends upon the source, what kind of source you are using. And as I said, it can be used for any material, for the bottles, baby bottles, nylon buttons, spray nozzles, surgical needles. It can be used for cutting, it can be used for engraving. The operations are very wide. Hmm. And engraving, it is very fast. Laser mein engraving is very fast. Hardly takes seconds, 2 seconds or 3 seconds. Of course, it depends upon what text is to be engraved. Hmm. The text is more than, but generally this laser engraving, it's any engraving. It will not take more than 10 seconds. Hmm. Then we have already discussed electron beam machining, but I just want to show you because here there are some you know easy sketches which will be useful for you, and then you can decide, because mostly I'll be sharing this presentation because this is important from your examination point of view. Hmm. See, remember the voltage, electrons are emitted at the speed of 3 into 10 to 8 meter per second, and see the voltage, it is 10 kilovolt to 50 kilovolt. 10 kilovolt मतलब देखो कितना 10,000 volt हो गया. Hmm. So you need to have a step up, kind of thing which will increase the voltage from our 440 volt to 10,000 volt or 50,000 volt. Hmm. And that is again a physics which you have learned uh, in electrostatics, that, and in engineering physics also you have learned, and that's why this physics is kept in the first year. Hmm. So this is a simple sketch electron beam machining. So you have a heater, and we call this as a cathodic emission. So this is connected to the negative, and you have a workpiece which is connected to the positive. Workpiece is called the anode. Electron emitter is called the cathode. You have a heating element which heats, and this particular emission is called the thermionic emission. Then depending upon the voltage, this voltage, that is, or rather voltage difference, or you have learned about stopping potential. The moment the voltage is more than the stopping potential, electrons, you know, gets attracted to the positive. Hmm. These are the focusing coils, and you also have the deflecting coils also here. So, which can be used to deflect the electrons, so that it covers the entire area of the workpiece. And this entire process happens in a vacuum, because if it interacts with oxygen, some reactions will take place. Mm. So vacuum pump is required to create a vacuum. To create a vacuum, see, creating a vacuum is not a joke, because it has to be totally sealed. Even if a small opening, mm, then the outside oxygen from the atmosphere will go inside, and it will spoil the vacuum. So this sealing, see, if you want to create a vacuum, that means you should have something to remove the oxygen which is there inside the room. So that means you need to drill a hole in this chamber. You need to drill a hole. The moment to drill the hole, that means what, you are allowing outside air to go inside, inside air to go outside. So now you have to see that outside go inside, only the inside one comes from outside. So even if there is a slight, opening, slight gap, since the outside pressure is more, the outside air will go inside, and that is why it becomes very expensive affair, vacuum pump, or anywhere vacuum. So it depends upon how much vacuum is required, and what is the quality of vacuum you require. If it allows some residual oxygen or some traces of oxygen, then it is fine. But if it doesn't allow small trace of oxygen, then it becomes a very expensive affair. 30 microns, that is little more than our hair hole is possible. And basically all these small holes are required in your medicines and in your electronics. Good finish You can get a good finish 0.4 to 0.6 microns. Hmm. Then you problem is if the holes are bigger than zero point 0.1, then you get secondary discharge which we discussed yesterday, and because of that you don't get a straight holes. You get a slight taper of 1 to 2 degree. So you have to compromise on the cylindricity because of the it is mainly because of the secondary discharges. These are the applications. Mainly EBM is used for drilling and slotting and not for the engraving. And again, drilling slotting on the very hard material, very hard material like ceramics. Then you have plasma arc machining. Plasma again is the fourth state of the matter. See, everywhere the principle remains the same. It's like your CNC milling machine, whether you talk about electron beam machining, whether you talk about laser beam machining, or whether you talk about abrasive jet machining. The setup is more or less same. It looks like your CNC milling only. Only in CNC milling there is a milling cutter end mill, and here the cutting tool goes on changing. In EBM you have electron, in laser LBM you have laser, in AJM you have abrasive jet, in plasma machining you have plasma. And then depending upon the characteristics of this source, cutting source, you have to design your machine tool. That's all. So here now you have a plasma gas which is passed and which is used for eroding the workpiece. So gases such as argon, they are ionized by pressing an arc across the gas flow. Then dissociated gases produce temperature so high, 16,500 degree Celsius, not Fahrenheit, Celsius, which vaporizes the work. So initially you have to struck the arc across the tungsten cathode. Why you are using tungsten? Because it has to withstand such a high temperature. Water cooled copper nozzle. Hmm. So you have two electrodes, that is cathode and anode. Cathode is negative, that is tungsten. Anode is positive, that is connected to the copper. Power supply is 100 to 200 volts and ampere is more, that is 100 to 300 amperes is used. You have comparatively higher material removal rates, that is 250 to 700, 1700. Hmm. So feed rates are very high. You can cut at these feed rates. Again, accuracy is a question mark in plasma arc machining. You don't get good accuracy. Hmm. Basically, it's rough. Hmm. Only advantage is your material removal rate is good and it can cut the harder material. So generally it is used for roughing work like profile cutting in stainless steel. Like you must have seen the gas cutting in workshop. Gas cutting, you do the gas cutting with the help of the torch, oxyacetylene torch. So that is called the oxyacetylene gas cutting. So here you can use instead of oxyacetylene gas cutting, you can use plasma. So you can describe, you can draw the sketch. Plasma arc machining is not that important from examination point of view. But what I was telling that abrasive jet machining is important. Abrasive water jet machining also you can write. Electron beam machining you can write where the electrons are used. Laser beam machining is important examination. So that is fourth one. Then fifth one we saw that is plasma arc machining. And now sixth one is ion beam machining. So here the cutting is done with the help of the accelerated ions. Like your electron beam machining, there is a kinetic energy. Hmm. So these accelerated ions are bombarded toward the workpiece, and then metal removal takes place because of the dislodging of the molecules. And remember, there is no heating here. The molecules are removed. Hmm. And then one molecule, two molecules. So like that, if you removed millions of molecules, means you can say that the material is cut or the material is eroded. Again, the machining is or material removal rate is not that good here in IM beam machining. Iron beam machining is not important from examination point of view. So it can be used like your milling or micro machining of electronic components like computer parts. It can cut the material like glass, pots, porcelain, which are very hard. So you can very well skip iron beam machining. I think it is not there in the syllabus also, but just that you should aware that there is something called as the iron beam machining also. Hmm? See, there are many unconventional machining processes. In based on the principle of magnet itself, there are unconventional processes: magnetorheological, magnetomotive, electromagnetic. Uh, four based on only magnitude, but those are all not practical. So that's why they are not popular. Of course, every process it has its own unique advantages. The processes are useful in research work or very high tech or precision industries like space industries, BRC, TIFR, those. Now, chemical machining is nothing but you are removing the material with the help of the chemical. So there is a chemical reaction which will take place between the chemical and the component. Now it is your skill, that is what to remove and what not to remove. So whatever you want to remove from the workpiece, you don't cover it, and whatever you don't want to remove, you cover it, and that is what is called the masking. So the masked regions or the masked areas, the material removal will not happen, and the material removal will take place only from the unmasked region. So this preparation you have the customer or the person has to do when he's going for chemical machining, and the masking proves to be very important in chemical machining. So what are the, and this masking is nothing but it is called the maskants. It's called the maskants. So maskants can be made up of different material like plastics, then ferric chloride, hmm, and you'll have to check the compatibility of the uh, maskants with your workpiece material. Like now, ferric chloride can be used for copper or MS. And again, not only with the workpiece material, but the compatibility has to check with the acid also. And that too, whether dilute, concentrated, pH value, everything has to be checked. So, which maskant will stand for which kind of acid? So that has to be checked. So that compatibility you will have to ensure. Chemical machining का shallow wide cavities on the plates. Then electronics manufacturing, there is small wafers. Wafers means films. Then etching of the glass with the help of these acids. It is H2FL, that is hydrogen fluoride, hydrofluoric acid. So in chemical machining, the material is removed, selected material is removed by the chemical. How it is prepared? They are first thoroughly cleaned, then degreased, then coated with a cut, and maskant is applied, and then a shape is cut by dipping it into a tank of chemicals. And then that chemical will dissolve the part which is exposed. So again here the material removal rate will depend upon how much time the workpiece is kept in the tank, and other factors like what is the acid, what kind of acid, what kind of maskants, then what is the strength of the acid. hmm. So that all will determine the material removal rate. You get a good accuracy of plus minus 50 microns. 0.05 nothing but 50. You have to always multiply by 1000. So this is 5 by 100 into 1000. So that is 50. Surface finish is not that bad, but it is not that good also. Its minimum is 0.25 microns is actually not a good surface finish. We are talking about zero point 0.1 or less than zero point 0.1 RA value, 0.05, 0.02. Material removal rate is slow or low. There is a limitation that how much deep you can go. This generally it is chemical machining is used for etching, and that's why it is also called as the chemical etching. So the depth of the marking, like suppose if you want to engrave your name like Sahil, or say other CRC, if you want to chemically etch it, the depth cannot be more than 12.7, and it has to be more than 3.8. So should be between 3.8 to 12.7. So, what are the applications? It's used where the depth of metal removal is critical, that is to a few microns, and for the casting, forging, stampings, aerospace, automotive, electronic, instrument making. This is also very useful application, that is decorative parts on elevator doors. Photochemical machining is also a part of the chemical machining, and this is the flow diagram. That is, you have to clean, apply, resist. In photochemical, you need to expose it to ultraviolet exposure. Then you have to develop it and then etch it. So the portion which is to be etched is exposed, and then you have to strip it. So this is what is your photochemical machining is, which is somewhat to your screen printing. Screen photochemical machining brings then after chemical machining there is another process, important from examination point of view. Examination point of view, abrasive jet machining, abrasive water jet machining, then your electron beam machining, laser beam machining. Plasma chemical is not. In electrochemical machining, the electric current is fast. So it is exactly the gold plating. So in electroplating, we deposit the material in order to improve its characteristics.